Hello everyone. Today's topic is probability. What do you mean by probability and what is the basic concept and theory about it? So let's see in this part 1 how likely something is to happen. And just stay tuned for the part 2 in which we are going to solve the applications based on this. So let's see. Okay, so what is a probability or possibility of an event? So it is a branch of mathematics that deals with the likelihood of occurrence of a random event. Random event is any experiment, any situation which you are doing, like throwing a dice, tossing a coin, or playing any game. Okay, so that is an event. And what is the likelihood of occurrence of the event means how many times, what is the possibility of getting a head, what is the possibility of getting a tail, what is the possibility of getting a 1 on a dice, what is the possibility of getting a 2 on a dice, or what is the possibility that the sun will rise today, what is the possibility the sun will not rise today. So all these possibilities, likelihoods will study under this branch of mathematics called probability. It is a branch of mathematics that deals with the calculation of chances or possibilities. So it deals with the chances or possibilities, calculation of these possibilities. Like what is the possibility that sun will rise? What is the chance of getting a 2 on a dice or head on the coin, or winning a game or losing a game? So all these possibilities, all these calculations are done under this branch of mathematics. Probability is always between 0 and 1 means if you are calculating the probability of any event, that will always lie between 0 and 1. It will not go beyond these numbers. 0 means the event will never happen. So, if what is the possibility the sun will not rise today? Or what is the possibility of getting a 7 on a dice? So, what is the possibility of getting 7? 7 will never come on the dice, right? So, the possibility of this event happening is 0. And similarly, 1, if the event is always going to happen, like the sun will rise today, sun will always rise, so that means the possibility will be 1. The probability of all the events in a sample space adds up to 1. What is a sample space? Sample space is a collection of all the outcomes of an event. Like if you throw a coin, so the outcomes can be head or a tail. So that makes a sample space, right? And probability of all the events adds up to 1 means probability of getting a head plus the probability of getting a tail. If you add both the probabilities, it should add up to 1. Similarly, the probability of winning a game, probability of losing a game. So both adds up to 1. Probability of getting 1, 2, 3, 4, 5, 6 on a dice should add up to 1. So always the probability of mutually exclusive events will add up to 1. All these concepts will learn in detail in the further video. Next is the formula for calculating the probability. So the first and foremost thing is the formula. The formula says P of E. P of E means probability of an event is the short form. P of E is equal to number of favorable outcomes upon total number of possible outcomes. So whatever are the possible outcomes of a probability will be like if you throw a dice. So possible outcomes are 1, 2, 3, 4, 5 and 6. So there are 6 possible outcomes, and number of favorable outcomes means whatever the question is being asked to you, like if the question is even number, chances of getting an even number, so you'll calculate how many even numbers can be there. There can be 3 even numbers, 2, 4 and 6. So probability of favorable outcomes will be 3 and probability of total possible outcomes will be 6. So answer will be 3 by 6. So this is how we are going to calculate the probability. Next is how we see the probability. So for any event, this is going to happen every time. Firstly, impossible event. Impossible means, as I've told you, sun will not rise today. So this is an impossible event. So obviously, for impossible events, the probability will always be 0, right? And in the last column, it is written certain. So obviously, certain means, if it is certain, that means it is going to happen. So obviously the probability will be 1. And if you say a dice is thrown to 1 in 6. So if you say what is the probability of getting a 4 on a dice? So probability will be 1 out of 6 chance, right? So 1 by 6, right? Then even chance. Even chance means half, like if you throw a coin. So getting a head and getting a tail have equal chances. Once out of 2 chances you get head, and once out of 2 chances you can get tail. So it is 1 by 2, 1 by 2. So even chance means both the outcomes have equal possibilities. Next is if you have taken out one petal out of 5 petals of a flower, so the probability of breaking another one is 4 out of 5 in chance. So it is likely event, right? So all this happens between 0 and 1. This is what is the summary of this picture, that every event, every probability, every possibility can only happen between 0 and 1. Okay, so next thing is types of events. What different types of events you can have. As I told you before as well, certain event is the event which will definitely happen. Like the sun will rise today. So obviously sun is going to rise, right? So the probability of those events are always equal to 1. Okay, that are certain events. Impossible events are the events that cannot happen. Means if you say a probability of getting a 7 when you throw a dice. So when you throw a dice, you are never going to get 7, right? So this event will not never happen. So these kind of events are called impossible events, which are not possible. So the probabilities of such events are always equal to 0. Okay. Next is random event. Random event is an event with uncertain outcomes. Means the outcomes can be between 0 and 1. Anything between 0 and 1. Those events are called random events. Anything between 0 and 1. Right? Complementary events. Complementary events means if event A occurs, the event A dash will not occur. Means complement means it is a complement of the event occurring. So if I say what is the probability of getting a 1 on a dice, so what is the complement of this event? What is the probability of not getting 1 on a dice? So this is a complement, the negation, right? In simple words. So for example, if an event is drawing a red card, the complement is not drawing a red card. So that is a negation of the event. That is called a complement. Okay, so let's move on. Next is an example of tossing a coin. So one by one we'll take the examples of the events and we'll tell you about how the sample space is being made, and what are the possibilities, what are the probabilities of these events. So if you toss a coin, the coin has two possible outcomes, head or tail. Probability of getting a head will be 1 by 2. Means out of 2 chances, there is a possibility of getting a head once, right? And what is the probability of getting tail? Out of 2 chances, 2 outcomes are there, head and tail. So the total outcomes comes in the denominator, and on the numerator there is number of favorable outcomes. So how many tails are there? 1. There is a 1 tail in every coin, so 1 by 2. So both the probabilities are 1 by 2, 1 by 2, that is 0.5. Obviously you can see here this is a random event because the probability lies between 0 and 1. Okay. Okay, so now let's move on. We'll make a sample space of the coins. 1 coin, 2 coin and 3 coins. Okay. So if you will toss 1 coin, you will get, as I have shown you in the last slide, you'll get 2 outcomes, head and tail. Okay. Now, if you toss 2 coins simultaneously, what will be the outcomes? In the first coin, either head can come or the tail can come. And in the second coin, again, head can come and tail can come. So the outcomes will be head on both the coins, head on the first, tail on the second, tail on the first, head on the second, and both the tails. So these are the 4 outcomes if you toss 2 coins simultaneously, right? As I have shown you in the flow chart. Nextly, if you have 3 coins, so what are the possible outcomes? Similarly, you can do, it is either 3 heads, head, 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 or either two heads and one tail, head, head, tail, or either head, tail, head, or either head, tail, tail, or tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. So these are actually 8 outcomes which you can get if you toss 3 coins, either one by one or either simultaneously. So if you have n number of coins, how can you get the number of possible outcomes? So possible outcomes comes with the formula 2 to the power n. So 2 to the power n is a formula for calculating the outcomes of tossing a coin. So if you toss it once, so it will get 2 to the power 1, that is 2 outcomes, head and tail. If you toss 2 coins, it is 2 to the power 2, that is 4 outcomes. If you toss 3 coins, it is 2 to the power 3, that is 8 outcomes. So this is how you're going to calculate the number of outcomes by the formula 2 to the power n. Next one is the sample space for a dice. If you throw one dice, you know you have 6 outcomes, 1, 2, 3, 4, 5, 6. Now if you throw 2 dice simultaneously, so you will have these all outcomes. These coordinates are actually the combinations which can come. Okay, so how this is being made? Either you can get the first coordinate shows you the number on the first dice, the second coordinate shows you the number on the second dice. So if you get 1 on the first dice, you can get 1 on the second, or 2 on the second, or 3 on the second, or 4 on the second, or 5 on the second, or 6 on the second, right? So this is how all the sample space is being made. Here we can use the formula 6 to the power n. So if you toss it once, so it's 6 to the power 1, that is 6 outcomes. If you toss it twice, so 6 to the power 2, that is 36 outcomes. So, and so on. Okay. So mainly you need to understand about at least 2 dice simultaneously. So this is an important part. So you need to know. So this is a sample space which you're going to get if you toss 2 dice simultaneously. Now this chart show you the all the possible outcomes in a deck of 52 playing cards. You all have seen the playing cards. So you have 4 set of playing cards, each having 13 cards, 4 shapes. 4 shapes are clubs, diamonds, hearts, and spades, and each shape have 13 cards. And what are those 13 cards? 1 ace, 2 up to 10 numbers, 2, 3, 4, 5, 6, 7, 8, 9, 10, and Jack, Queen, King, JQK. So these are the set of 13 cards of each shape. Okay, so you have 4 shapes, and in each shape you have 13 cards. So in all 52 cards you have in a deck of cards. Okay, so clubs, diamonds, hearts, and spade. 2 are black in color and 2 are red in color. So you have to understand all these things. And these Jack, Queen, King are called the face cards. So whatever, if your face is shown on that card, that is called face cards. So in all you can see that 3 face cards are there in each shape. So that means 3 into 4, 12 face cards in the whole deck of playing cards. Okay, so there are 12 face cards, 4 aces, and all others are numbers from 2 up to 10. Okay, so just remember these things and remember the shapes and remember the number of cards. Now next thing is experimental probability. So what do you mean by experimental probability? Experimental probability is a probability of an event occurring based on repeated trials or experiments. So if you make a repeated trials or repeated experiments, like 2 times tossing of coin, 3 times tossing of coin, 2 times tossing of dice. So these are repeated trials. So the probability formula is number of successful trials upon total number of trials, like rolling a dice 10 times to find the probability of getting a 6. So successful repeated trials are called experimental probability. If you toss coin 100 times and get 55 heads, so experimental probability is total number of times the trial is being made 100 times, and successful trials are 55. So 55 upon 100. Next is theoretical probability. Theoretical probability means probability of an event occurring based on number of favorable outcomes and total number of possible outcomes. So it is what just what we have done earlier, the number of favorable outcomes upon total number of possible outcomes. For example, find the probability of getting a head when flipping a coin once. So experimental, you can have large number of trials, but in theoretical probability, just have limited number of trials, and you will find the when you have you can find the probability of getting ahead when flipping a coin once. Okay, so next thing is coincidence. So what do you mean by coincidence? When two or more events occur together. And another thing is mutually exclusive, when two or more events cannot occur together. For example, for coincident event, you can take when two or more events occur together. Means if you take, when you throw a dice, what will be the probability of getting an even number, right? So probability of getting an even number and probability of getting a prime number. So if these are the two events, so they can occur together. Means what if you take out the probability of getting an even number, so that will be numbers 2, 4 and 6, and probability of getting a prime number is 2, 3 and 5. So 2 is occurring in both the events, so it is a coincident event, right? And mutually exclusive means when two or more events cannot occur together. That means if you say a probability of getting an even number and probability of getting an odd number, so they are mutually exclusive. So either it can be odd or it can be even, but they cannot be same at the they cannot be equal at the same time, right? So they are mutually exclusive, even number and odd number. So they are exclusive events, and coincident means two or more events can occur together. For example, a rolling of die of getting a 2 and a 5 at the same time. Okay, so that is probability of combined events. Probability of combined events, we have two rules in that, addition rule and multiplication rule. So what do you mean by addition rule? Addition rule means probability of getting A or B, means probability of getting 2 or 5. So what will be the probability of getting 2 or 5 will be probability of getting 2 plus the probability of getting 5. Okay, we'll add both the probabilities. And if you'll say multiplication rule, so this is probability of getting 2 and 5. So 2 and 5 will be probability of getting 2 into probability of getting 5. So if you are saying or, so you will add up the events. If you are saying and, so you will multiply the probabilities. So these are the two rules. Now, what is the application of probability in real life? So application is, first of all, is risk assessment. So what is a risk in, if you are taking any like in stock marketing and everything, you have a risk management skills, right? That means you have a risk assessment. मतलब you will assess the probability of occurring of the event, occurring of a profit or a loss. So all these assessments are done with the help of probability. Then medical diagnosis, all medical diagnoses, in some of the medical diagnoses also we use probability. Thirdly is weather forecasting, like as I told you, it will rain today or it will not rain today, what is the probability, what is the possibility. So all these things are done under weather forecasting. And next is sports betting. Obviously in sports betting, like whether they're going to win the match or they're going to lose the match, all these things depends on the probability or possibility of an event. So all these areas use they take the help of probability, right? So thanks for watching. Please like, subscribe my channel and share the video and Stay tuned for the part 2, as the part 2 is coming with more of the questions, more of the applications based on all these concepts. So stay tuned. Thank you.